Article 250.112 of the National Electrical Code addresses separate grounding electrode systems. Article 250.50 pertains to the grounding electrode system. An electrical installation involving a 400 amps 120/240 volt single-phase service in a single-family home with a 400 amps meter base and parallel conductors running to two 200 amps main circuit breaker, abbreviated MCB, panel boards, each have a grounding electrode conductor, abbreviated GEC, to an exterior-driven ground rod, and no bonding between the panel boards, raises several code compliance questions. The described installation, featuring two 200 amps MCB panel boards connected in parallel, each with a GEC to a separate ground rod, is generally acceptable under the NEC. Article 250.112 allows multiple grounding electrodes for a grounding electrode system, abbreviated GES. In this scenario, the GES consists of two driven ground rods and the grounding electrode of the meter base. Article 250.50 mandates a separate GEC connected to the ground terminal of each panel board, ensuring each has a dedicated path to ground. Since the two 200 amps MCB panel boards are connected in parallel, they are considered a single electrical system, eliminating the need for additional bonding between them. The installation of a ground rod at an exterior water well aligns with NEC requirements for grounding water systems. The approval from the local electrical inspector indicates compliance with local safety and code standards. The installation described aligns with the NEC guidelines. Each panel board has a separate GEC, and the GES includes multiple grounding electrodes. The absence of bonding between the parallel connected panel boards is not an issue. The inspector's approval further validates the installation's acceptability. In summary, firstly, Article 250.112 addresses separate grounding electrode systems, permitting multiple grounding electrodes for GES. Secondly, Article 250.50 requires a separate GEC for each panel board to ensure a dedicated path to ground. Thirdly, parallel connected panel boards form a single electrical system, removing the requirement for additional bonding between them. Grounding at a water well follows NEC standards for water system grounding. Local electrical inspector approval confirms compliance with jurisdictional safety and code requirements. The key points are that the described installation is generally acceptable under the NEC. Each panel board has a separate GEC, multiple grounding electrodes are part of the GES, and bonding between the parallel panel boards is not necessary. It is crucial to understand the NEC references that support this type of installation. Article 250.112, separate grounding electrode system, allows for multiple grounding electrodes, meaning that you're not limited to a single ground rod or grounding electrode. Article 250.50, grounding electrode system, explains that each panel board should have its own grounding electrode conductor connected to the ground terminal. This helps ensure that each panel board has a direct and reliable path to ground. When panel boards are connected in parallel, as in this case, they essentially function as a single electrical system. Because of this, the NEC doesn't require additional bonding between the panel boards. The ground rod installed at the exterior water well is likely there to comply with NEC requirements for grounding water systems. This is a common practice to help prevent electrical hazards related to plumbing. The installation's approval by the local electrical inspector is significant. It indicates that the installation meets all the necessary safety and code requirements specific to your jurisdiction. This approval provides assurance that the work has been properly inspected and found to be in compliance. Overall, based on the NEC references and the information provided, the installation is generally acceptable. The presence of separate GEC for each panel board, the use of multiple grounding electrodes, and the lack of bonding between the parallel panel boards are all in line with code requirements. The local inspector's approval further confirms the installation's compliance and safety. It's important to remember that electrical codes and regulations can vary by location. Always consult with a qualified electrician and your local electrical inspector to ensure that your installations meet all applicable requirements. Firstly, understand the purpose of grounding. Grounding is a safety measure designed to protect people and equipment from electrical shock and damage. It provides a low resistance path for fault current to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. Secondly, know the components of a grounding system. A grounding system typically includes a grounding electrode, such as a ground rod or metal water pipe, a grounding electrode conductor that connects the electrode to the electrical system, and bonding jumpers that connect various metal parts together to ensure they are all at the same potential. Thirdly, recognize the requirements for grounding electrodes. The NEC specifies the types of grounding electrodes that are permitted and how they must be installed. Common examples include ground rods, metal water pipes, and concrete encased electrodes, often referred to as offers. Fourthly, understand the rules for grounding electrode conductors. The grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. It must also be securely connected to the grounding electrode in the electrical system. Fifthly, know the requirements for bonding. Bonding is the process of connecting metal parts of an electrical system together to create a low impedance path for fault current. This includes bonding metal enclosures, raceways, and equipment grounding conductors. Sixthly, be aware of the rules for equipment grounding conductors. Equipment grounding conductors provide a path for fault current to flow back to the source from metal parts of equipment. They must be properly sized and connected to ensure effective grounding. Seventhly, understand the specific requirements for different types of systems. The NEC has specific requirements for grounding different types of electrical systems, such as separately derived systems, generators, and services. Eighthly, stay up to date with code changes. The NEC is updated every 3 years, so it's important to stay informed about any changes that may affect your work. Ninthly, always follow manufacturer's instructions. When installing electrical equipment, always follow the manufacturer's instructions for grounding and bonding. Tenthly, if in doubt, consult with a qualified electrician or electrical inspector. If you have any questions or concerns about grounding and bonding, it's always best to seek expert advice. The grounding electrode system, abbreviated GES, is a crucial part of any electrical installation, serving as the primary connection to the earth and providing a low impedance path for fault currents. The NEC outlines specific requirements for the GES, ensuring safety and proper functionality. The grounding electrode is the physical connection to the earth. Common types include ground rods, metal water pipes, and concrete encased electrodes. Ground rods must be at least 8 feet long and driven into the ground. Metal water pipes must be in direct contact with the earth for at least 10 feet. Concrete encased electrodes, often referred to as U for grounds, must be at least 20 feet long and encased in concrete. The grounding electrode conductor, abbreviated GEC, connects the grounding electrode to the electrical system. The size of the GEC is determined by the size of the service entrance conductors. It must be made of copper or another approved material and be securely connected to both the grounding electrode and the neutral busbar in the service panel. The main bonding jumper connects the neutral busbar to the equipment grounding busbar in the service panel. This connection ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. Auxiliary grounding electrodes are additional grounding electrodes that can be used to supplement the main grounding electrode. These are often used in situations where the soil resistivity is high or where there are concerns about the effectiveness of the primary grounding electrode. Resistance to ground is a measure of how well the grounding electrode is connected to the earth. The lower the resistance, the better the connection. The NEC requires that the resistance to ground be no more than 25 ohms. If the resistance is higher than 25 ohms, an additional grounding electrode is required. Ground fault protection is a safety feature that detects ground faults and quickly energizes the circuit. This helps to prevent electric shock and equipment damage. Ground fault protection is required in many electrical installations, particularly those that serve commercial and industrial facilities. Bonding ensures that all metal parts of an electrical system are electrically connected, creating a low impedance path for fault currents. This helps to prevent electric shock and equipment damage. Bonding jumpers are used to connect metal enclosures, raceways, and other metal parts of the electrical system. The size of the bonding jumpers is determined by the size of the circuit conductors. Equipment grounding conductors, abbreviated EGC, provide a path for fault currents to flow back to the source from metal parts of equipment. The EGC must be properly sized and connected to ensure effective grounding. Separately derived systems, abbreviated SDS, such as generators and transformers, require their own grounding electrode system. The SDS must be grounded in accordance with the NEC requirements. The neutral conductor is the conductor that carries the unbalanced current in a 3-wire or 4-wire electrical system. The neutral conductor must be grounded at the service entrance and at each separately derived system. Grounding and bonding are essential for electrical safety. Proper grounding and bonding practices help to prevent electric shock, equipment damage, and fires. The NEC provides detailed requirements for grounding and bonding, and it is important to follow these requirements carefully. Firstly, grounding and bonding are crucial for electrical safety. Secondly, the grounding electrode system, abbreviated GES, provides a low impedance path for fault currents. Thirdly, the grounding electrode conductor, abbreviated GEC, connects the grounding electrode to the electrical system. Fourthly, bonding ensures that all metal parts of an electrical system are electrically connected. Fifthly, equipment grounding conductors, abbreviated EGC, provide a path for fault currents from metal parts of equipment. Sixthly, separately derived systems, abbreviated SDS, require their own grounding electrode system. Seventhly, the neutral conductor must be grounded at the service entrance and at each separately derived system. Eighthly, always follow the NEC requirements for grounding and bonding. Ninthly, consult with a qualified electrician if you have any questions or concerns. Tenthly, regular inspections and maintenance of grounding and bonding systems are essential to ensure continued safety.